Honorable Excellencies, Namaste. I would like to express my sincere thanks and gratitude for your guidance and support through digital learning to the aspirants and research scholars and subject matter experts about that specific topic related with space explorations. I would like to share my understanding about process documentation of digital learning. Explorations with respect to the published problem statement. Watched a broadcast from at NASA about the asteroid published 2 weeks ago, like an asteroid age approaching towards Earth with a speed more than 20,000 kilometers, and strategic measurements are required for dealing with the uncertain problems of that disaster management. Then I started watching a broadcast from IIRS ISRO Digital Learning Program from its IIRS Outreach Dehradun on their YouTube ID. The title of the broadcasted topic, India's Mission to Mars, was published on 7th May 2024 by Dr. Rishitosh Sinha. In the poolside menu of For You, a series of publications are recommended by the Information Technology Augmented Reality of Intelligence as follows, like वानिकी और परिस्थिति में सुदूर संवेदन तकनीक डॉक्टर हितेंद्र पडालिया, minor bodies, comets, asteroids and meteoroids by Professor Shashikiran Ganesh, planetary space weather, science and impacts by Dr. Smita Thampi, disaster management, what space contributes, introduction to atmospheric and cosmic hazards by Dr. Dimitra. Then geospatial research and modeling for heat waves, satellite-based monitoring of aerosol particulate matters by Dr. Yogesh Kant, laboratory analysis to understand solar system conditions by Professor Bala Murugan, सुदूर संवेदन के उपयोग से रात में पृथ्वी का अवलोकन श्री प्रसून गुप्ता, सैटेलाइट मॉनिटरिंग ऑफ रेनफॉल फ्रॉम VISIR and MW sensors by Dr. Charu Singh. Overview of planetary geoscience by Director NRSC, like meteorological observations were also shared. Geospatial research and modeling for heat waves and India's lunar exploration program by Dr. Vijayan S. Application of DIN SAR for disaster management by Sri Harishankar. Drought monitoring and assessment using remote sensing data by Dr. Bhaskar R. Nikam. GNSS application for atmospheric studies by Dr. The next one about overview of Earth observation satellites and sensors for atmospheric and ocean hazard studies, communication and navigation satellites and its application by Dr. D.K. Singh. Scientific preludes for solar system explorations by Dr. Mehul Pandya. Earth observations for agricultural monitoring and food security assessment, Indian Regional Navigation Satellite System IRNSS, Earth observation sensors and platforms by Sri Vinay Kumar, launch vehicles and propulsion system by Dr. V. Narayanan, application of GNSS for disaster management system by Excellency. Observation after the broadcast of the India's mission to Mars, the next broadcast on laboratory analysis to understand solar system conditions by Professor Bala Murugan started broadcasting itself or facilitated by playlist. Title of the presentation, like laboratory analysis to understand solar system conditions by Professor Bala Murugan. Note, key contents of the lecture and presentation could be noticed by viewers and reading research scholars to understand the presented perspective of the subject experts. Even subject experts could also refer and recommend the uploaded presentations during their further recommendations of that subject matter related discussions. Example, the chemistry in Earth atmosphere is discussed in the presentation, so that the key points of the presentation could be written or typed or recorded or downloaded by the viewers for further references. Respectively, the participatory learning process with ICT interfaces, information communication technology, could be developed by imparting learning skills capacity building training program. Like keywords or topics discussed in presentation relates with ozone, how ozone are formed, about photons, ion, water synthesis, physical state of water, chemical thermodynamics, and its related impacts on chemical reactions which occurs in outer space, like ice is permanently shadowed crater on the moon. Spectroscopy techniques is used for such observations on planetary bodies, chemistry on the surface of our moon, water and carbon dioxide iceage on lunar surface, H2O plus CO2, H2, CO3. Can we call this chemical complexity of the molecules or no? Such discussion to discuss. You can write, you can describe. Sublimations, photosynthesis, and vacuums are referred as frame of reference observations of physical and chemical changes. Mercury is referred as coldest and closest to Sun in solar system. Europa is the satellite of Jupiter with Io and Ganymede. Enceladus, Danae, and Rhea, and Titan are the satellites of Saturn. Triton is satellite of Neptune. Charon is satellite of Pluto. Charon. Then slide on chemistry in the icy outer solar system was share like planets, satellites, and ice like Jupiter, Io, SO2, SO3, H2S, and water were like input there. Jupiter, Europa, H2O, SO2, CO2, CX, HY hydrocarbons, XCN, H2O2, H2SO4, Ganymede like H2O, SO2, CO2, CXHY, XCNO2, O3. And Saturn for Enceladus H2O, Dione H2O, CXHYO3, Rhea H2O, CXHYO3, Titan H2O, CH4, C2S6, CO, NH3, Neptune, Triton, N2, CH4, CO2, CO, H2O, Pluto, Charon, H2, CH4, CO, H2O, NH3, NH3 hydrate. Learning remarks. Video lectures could be paused by clicking on this arrow button in YouTube application to take notes. CC could be clicked to watch the transcript simultaneously with the presentation. Arrow button besides the title of the topic could be clicked to watch the description of the presentation. Show transcribed button of navigation could be followed to watch the detailed notes of the transcripts of the presentation. Transcripts could be used for writing or typing as class notes or abstracts of the presentation. Notes from slide of the presentation like surface, secondary atoms, excited atoms or molecules, then secondary electrons, any ionized atoms or molecules, ionized hydrogen, nitrogen and oxygen is found in magnetosphere of Saturn, solar radiations causes chemical change of ionization potential and velocity of the atoms and valency of the atoms or electrons in atoms in outer space. Resultantly, chemical reactions takes place. What would be the impact of planetary system with or without atmosphere? N2CH4, CO, H2O, NH3 and NH3 hydrate are observed on Charon satellite of Pluto. About thing like notes from presentation like Arrhenius equation, pre-exponential factor K is rate constant, A is pre-exponential factor, E is base of natural logarithm, E is activation energy EA, and R is gas constant. Temperature in degree Kelvin is mentioned as T. Then Kuiper belt was also referred like chemical composition varies a lot, reservoir of long period comets, and its chemistry of Kuiper belt equivalent to interstellar chemistry. There are other notes that could also be taken from the presentation. Chemistry in the interstellar medium like governing equation is PV is equal to nRT, cosmic ray like molecular clouds, density per centimeter cube, temperature in Kelvin, diffuse clouds 10 to the power 2 or temperature 100 to 120 Kelvin, translucent clouds 10 to power 2 or 10 to power 3 and 50 to 100 kelvins need a surface for radiation or not, was the question asked. Astrochemistry is the branch of chemistry which deals with the chemical dynamics of the astronomical planets, satellites and comets, meteoroids and asteroids. Another presentation shares like astromaterials, like it may be ice or dust. Ice may be like observed by a spectroscopy, IR, T, Hertz, V or ultraviolet or AUV. Then residues like physical or chemical natures for MaON3 or graphene or PAH, poly like hydrocarbons or whatever it is. Then dust for synthesis, destructions will produce carbon or what we can say minerals or alloys or meteoroids or origin of life. It is related with Big Bang, I understand. Physical research laboratory avails information on research outcomes related with the subject. Then the next remarks of recommended video after presentation of the previous presentation topic, platforms for solar system exploration by Dr. Shamrao appeared itself. I have intervened, like my intervention, I have presented my presentation on strategic management. 4 pillars of presentation, preliminary explanations, origins 206, like overreaching science goals, pillar 1, key science questions, measurements, requirements, pillar 2, mission targets and types, then mission requirements, then manage about like what we can say, future technologies and future infrastructure and services management. Then key science questions like diversity of planetary system objects are under exploring diversity of planetary system architecture, then understanding diversity by origin of planetary system, then how do planetary system works, about this searching for inhabited world with the emergence of potential habitats or search for life. The 9 destinations were discussed, like the Earth Moon system, Venus, Mars, Mercury, giant systems, ice giant systems, small bodies, heliosphere, boundary, interstellar medium, extrasolar planetary bodies, about observational techniques like Earth or space based telescope for solar system, Earth or space based telescope for exoplanets, robotic explorations, flybys, robotic explorations in situ, what we can say, sample return, then human explorations. Then 7 types of space mission to observe planetary bodies were discussed, like observation from Earth and its orbits, meteorite collections, planets and small bodies, flybys, orbital explorations, in situ explorations, Vikram landers, rovers, robots, sample return, human explorations. Then steps of solar system exploration includes like remote sensing from Earth, Moon or L point, interplanetary or interstellar cruise, planetary flyby, planetary or satellite orbiter, single platform, multi-platform or probes or penetrators, small satellites, nano satellites, and in distant future chipsets, landers on planetary or satellite surfaces. Then lander with mobility, example like rover, crewlines, balloons, helicopters, submarines, surface sample return, sample curation, analysis of the Earth, components of lunar exploration architecture like international commercial launch of small landers, robotics precursors, unpressurized rovers followed by utility rovers, ISRU prospecting and demonstrations in lunar environment, large human rated rockets like for human exploration mission. Followings are the prerequisite presented into the presentation, like gateway, crew vehicle, fuel, reusable human lander, EVA suites, medium class cargo lander, small pressurized rovers, power installations on moons, then communication tower installation on moon, facilitated by utility rovers, ISRU system demonstrators, small scale productions, ISRU pilot plant, small scale demonstration and integrated system validation. Note, gateway habitation facilitates for Mars mission could be expanded by consecutive research and development. Operation of the communication channel between Earth and Moon crew members could be established. Then installation of nuclear power at moon for supply of day-to-day energy requirements of the habitating crew members of human settlements would be required. Installation of ISRU planet for full-scale production, fuel consumable infrastructure and recycling will be required. Installation of logistics module for long-duration habitation assistance to the human settlement on moon will be required. These are the projected domains of research, and enabling technologies will include like entry, descent, landing and ascent level management, robotic explorations, human explorations, in situ resource utilization, like entry, descent, landing and ascent EDCA of the mission module of moon are regulated phase way. Like entry, aero assist, hypersonic decelerator, descent like aerodynamic decelerator, supersonic retro propulsions, landing about touchdown system, autonomous targeting, assets like sample return, human class ascent system, node, landing are facilitated by parachute and power descent also. Observations linked to the related video presentations are also presented into the presentation, like Mars 2020 landing video on Mars, Mars sample return mission video. Robotic explorations like Chandrayaan 3 rover. Note, X-ray spectroscopy helps in monitoring of the mission. Future astronauts or astronomers robotic explorations, CADRA, NASA lunar exploration missions, human explorations includes like NASA human exploration of Mars video modeling, in situ resource utilization. Note, simulation on the basis of the data analysis of the sample from outer space objects helps in modeling and production of infrastructure and technologies which best suits with the environment where the proposed project interventions are assumed to take place. For human space explorations missions, system level technologies to fly and return are developed. Like this includes following steps: system engineering, propulsion power, deep space communication and navigation, autonomy and health management. Subsystem level technologies for solar system explorations are described as follows, like sensing and perceptions, like a stereo version leader, proximity sensing, pose velocity and inertia estimation, terrain relative navigation, hand-eye system, sensor fusion, about mobility, SLM, hazard detection, path planning, mechanism, collaborative swarm, exoskeleton planning under uncertainty, about manipulation, motion planning, contact sensing and manipulations, lightweight structures, drilling, sample handling, multi-arm or finger manipulations, planning under uncertainty. Then autonomous docking includes like relative navigation, docking interface, proximity operations, standardization. Human system interaction includes like crew decision support system and immersive visualization, visual data presentations, displays and control, haptic displays and controls. About autonomy, like a spacecraft controls health progenesis and diagnostic, human life support system, planning and scheduling of resources, operations, FDIR, software reliability. Then system engineering includes like human safety, modular serviceable interfaces, COTS technology, thermal control, verification and validation, modeling and simulations. About planetary system like landing system, surface robots, aerial robots, underwater robots, swarm robots, sample collection and return, small explorations. About orbital system, in orbit servicing, in orbit manufacturing, in orbit assembly, autonomous docking, exploration, orbital docking and docks, small sample deorbits. Human exploration system like teleoperation, astronaut assistance, human robot interaction, crew surface vehicle, human habitats and crew orbital vehicles. About rovers like wheeled rovers, walking rovers, aerial rovers, robot swarms, robotic arms including rover, mounted arms, sample handling arms, servicing arms. About docking systems, 6 DOF docking bands, small satellite docking system, air bearing test tables, breathing or birthing simulators, human robot system like teleoperations, robotic arm simulators, Astro Assist robots, orbital vehicle simulators, crew vehicle simulators, EVA simulators, and humanoids. About test facilities like drop test bay, outdoor or indoor, sensor suite system, pro propulsion test platform, landing propulsion test, Mars or lunar yards, vision text system. Remarks: obedience of quality management system manual for each steps assures safety of the mission. Dr. Samro mentions about Galileo methodology in his presentation on platform for solar system exploration as follows. Galileo methodology. Galileo identified key scientific problems. He took existing technology and developed it into a new level. He then used it to solve problems, leading to a virtuous spiral of scientific and technological progress. He therefore left both science and engineering enhanced, and he was motivating rather disruptive. Respectively, other members or aspirants could learn about different subject matter into this system. It will be helpful. Thank you.